Hello and welcome, dear mathletes, once again to Mathlete Mind. We continue our journey of CBSE Class 10 Mathematics, and this time the topic that we are going to focus on is pair of linear equations in two variables. Now, what exactly are we going to do with this topic over here? We'll find solutions of pair of linear equations in two variables in different methods, algebraically as well as graphically. But before we do that, let's have a quick recap of linear equation in two variables. Now, linear equation in two variables over here, this two over here, two variables, has got a standard form ax plus by plus c is equal to 0, where a is the coefficient of x, b is the coefficient of y, and c is a constant. Now, what we need to keep in mind over here is whenever we are talking about the coefficients and constants, if they are positive, of course, it's okay. But if they are negative, we have to be extra careful while plotting the graph or while finding different solutions of x or y corresponding to solutions of y and x. So here supposing I've taken here one example, x minus y minus 6 is equal to 0. Very simple question without any coefficients. Coefficient of x is 1, coefficient of y is negative 1, and the constant is negative 6. So now to plot the graph over here, supposing we need minimum 2 points. You can take as much points as possible, but minimum 2 points are required. And how do we select the points? I can rewrite this equation. If you, this is a simple equation, but still if you want, you can write it in this format. So if y is 0, x will be equal to 0 plus 6, that is 6. So y is equal to 0. If you put x as 0, if I take x as 0, in that case, y is equal to minus 6. So this 2 points are enough. X is 6, y is 0. So this is the point over here. Y is, then x is 0, y is minus 6. This is the point here on the y-axis. So join these 2 points and you get a straight line. The graph lines will always be straight lines in these cases. Now, there are different things that can, different other conditions that can arise. Sometimes what happens is b is 0. In that case, ax will be equal to minus c. So, x will be equal to minus c upon a. If this ax is 0, that means y is equal to minus c upon b. So, minus c upon a and minus c upon b, they are constant. So, now see what are the different types of graphs we will get here. Supposing in this particular question, if I put y as 0, I'll get x is equal to 6, this equation. And when we draw the graph line of x is equal to 6, it will be a line parallel to the y-axis. Because whatever value of y you take, the value of x will remain constant, that is 6 in this case. So the line will always be parallel to the y-axis. If it is negative 6, it will go on and go to the other side. If, here it is a positive 6, so we draw it over here. Whether the y value is negative infinity to positive infinity, the x value remains unchanged. Now, supposing in this case, x becomes 0, then y is negative 6 in this particular question. So then we draw a line parallel to the x-axis passing through the point negative 6. So whatever be the value of x from negative infinity to positive infinity, y is going to maintain at minus 6 over here, a line parallel to the x-axis. Now, there can be another condition. Supposing this constant becomes 0. So in this case, if the constant becomes 0, we get here y is equal to x. Other cases will also be there where the constant is 0. So in the y is equal to x for this particular case, but supposing there are coefficients of x and y, accordingly the equation will change. So here we are getting y is equal to x. This means that whatever be the value of x, we have the same values of y. So if x is positive 1, y is positive 1. X is positive 2, y is positive 2. That means both the points will, for x and y, corresponding points are in the first quadrant. Similarly, if x is negative 1, y is negative 1, negative 2, negative 2. So the first and third quadrant will be the quadrants through which the line will pass, and it will always pass through the origin. Remember, if this c is 0, it will always pass through the origin. Supposing y is equal to 2x. Supposing there is a coefficient of x, supposing it is like this. So in that case, if x is 0, y is 0, it is going to pass through the origin. If x is 1, y is 2. If x is 1, y will be 2. So the graph line will be slightly, it will move closer to the y-axis. So this way you have to draw the graph lines. The angle of inclination will change of this line. That is the graph line with the y and x axis according to the coefficients of x and y. Now supposing y is negative x. So y is negative x, again the graph line will pass to the origin. But here we notice that if y is negative x, supposing x is equal to 1, y will be negative 1. If x is equal to 2, y will be negative 2. So this line will pass through the fourth quadrant. If x is negative 1, y will be equal to minus into minus 1, that is positive 1. So similarly, if x is negative 2, y will be positive 2. So the graph line will pass through the second and fourth quadrant. So this also you need to keep in mind. And as in the previous case, whatever be the coefficient, according to that, the angle of inclination will shift towards the x or y axis. Now we have pair of linear equations in two variables. So here, what do we do and how do we solve this graphically? So these are the two equations. So these are the general standard representations of the two equations or linear equations. A1x, b1y, c1 is equal to 0. a2x plus b2y plus c2 is equal to 0. Now what do we need to understand over here is before we plot the graph, this is mandatory. Before you plot the graph, you take out the ratio of the coefficients and constants. That is a1 by a2, b1 by b2 and c1 by c2. Now the moment you realize that a1 by a2 is not equal to b1 by b2, don't proceed for the the same coefficient. This is enough to suggest that the two graph lines will intersect at a particular point. So once you know that the graph lines are going to intersect at a particular point, you will be focusing to draw the graph lines that way. So let us see, we have taken here a very simple example, x minus y is equal to 4 and x plus y is equal to 10. So here again, x is equal to y plus 4. If y is 0, x is equal to 4. If y is 0. And if x is 0, we get here y is equal to minus 4. So my y is minus 4, x is 0, y is 4, x is 0, sorry, x is 0, y is 4. Here this will be x is 0, y is minus 4, y is 0, x is 4. So this is the graph line. Similarly, x plus y is equal to 10. If y is 0, x is 10, x is 0, y is 10. So it passes to 10, 0 and 0, 10, both positive. And they intersect at this particular point over here. Now, what is this point of intersection? This is 1, 2 over here, 7, 3. So the point of intersection is 7, 3. The next case is when the three ratios, when we come across the ratios and we find that first two ratios are equal, but the third one is unequal. So in this case, we will always get a pair of parallel lines. They will never meet at any particular point, though extended to infinity on either side. So here there are two equations over here, just for understanding. Now this is a1 by a2 is 3 by 6, that is half. b1 by b2 is again half. c1 by c2 comes as minus half. So though there is a sign difference, that means they are unequal. So we'll get two parallel lines. So in a similar way, by taking 2 points over here, this graph line has been plotted, that is 3x minus 5y is equal to 20. So if we take 3x minus 5y is equal to 20, put y as 0. Then in that case, x will be equal to 20 by 3, that is 6.6. And if x is 0, in that case, if x is 0, y will be equal to minus 4. So here the scale is taken has been taken as 1 division as 2 units. So minus 4 comes over here and 6.6 comes over here. So the graph line passes through these 2 points and it has been extended on either side. Similarly, this one 6x minus 10y is equal to minus 40. So here if I put y as 0, x is equal to minus 40 by 6, that is minus 20 by 3. That is minus 6.6. So it will go on this side at the same distance. This is 6.6 on the right side, 6.6 on the left side. Similarly, if I put here x as 0, y will be equal to 4. X is 0, y is equal to 4. This is the point over here. So the graph line can be drawn and they will never meet at a point. This is the second case. The third case is where all the three ratios are equal. When all the three ratios are equal, like A1 by A2 is half, B1 by B2 is half, and C1 by C2 is half, then in that case, the graph lines superimpose over each other. You need not even draw two different lines. One line is enough to suggest that the graph lines are there and they are superimposing over each other. So these three conditions are very essential before you draw the graph. Identify the ratios, check out what the ratios are suggesting, and then you sit and draw the graph. Next thing is some questions pertaining to these graphs. So first of all, on your graph sheet, you need to first draw this, keep the scale over here, write the scale on the right hand side top. Now here, getting back to the two equations that we have been given, x minus y is equal to 5, 2x plus 3y is equal to 15. Checking on a1 by a2, a1 by a2 is half, b1 by b2 is negative 1/3. Obviously, they are unequal. So that means the graph lines will intersect each other. So first what we do is we take this equation and supposing you can rewrite this as y plus 5. So if y is 0, x will be 5 if y is 0. If x is 0, y is equal to negative 5. So we take the chart over here and write down the points. This is 5 and this is 0. If this is 0, this is negative 5. Then we have this equation 2x plus 3y is equal to 15. So if x is 0, y is equal to 5. And y is 0, if I take y as 0, x will be equal to 7.5. That means if I take this, if x is 0, y is 5. If x is 7.5, y is equal to 0. Alright, y is equal to 0 when x is 7.5. So now on this graph sheet, let us take the first one, 5, 0. This is the point 5, 0. And 0 minus 5 is this point over here. So we'll plot the graph line over here, right? This is the point here. So let us join these 2 points over here. The graph line goes like this. And you can extend it on either side. It has to be passing through this point over here. And point over. 1 second. Is to go through this point, so let me extend it downwards also. So this is the graph line for the first equation. For the second one, we have 0, 5. 0, 5 will come over here. And 7.5, 0. Here I've taken one division as 1 unit. So 7.5 will come over here. 7.50. So these 2 points have to be joined now. To join these 2 points, we have this graph line passing through this and this point over here. So this is the graph line over here. And it go like this, a bit this way. Let me extend it over here, passing through 0, 5. And this, so now I just change the color of this, right? One, let me put it as red. So this is the second graph line, this is the first graph line. So now you find that they are intersecting at one point. What is the point of intersection? 6, 1. The second question that is there is find the coordinates of the vertices of the triangles bounded by these lines in the y-axis. So now which is the triangle that we have to consider? We have to consider this triangle. This is the vertex A, this is the vertex B, and this is the vertex C. So the coordinates of A will be 0, 5. Coordinates of C will be 0, minus 5. And the coordinate of B will be 6, 1. So these are the, because it is saying y-axis and the two lines, you have to find that. If supposing it was x-axis and the two lines, it would be this small triangle over here. So moving on to the next question, solve the following system of equations graphically. Find the area bounded by these lines on the x-axis. Now we are given here area bounded by these lines on the x-axis. So let's see what we need to do over here. First of all, check a1 by a2, b1 by b2. They are not equal, so the points will be intersecting. Now taking the first one, x minus y plus 2 is equal to 0. So if we put x, we can write this as y minus 2. So if we put y as 0, x will be equal to minus 2 when y is 0. If x is 0, over here, if we take x as 0, y is equal to 2. So we'll put the values here, x, y, this is minus 2, this is 0, this is 0 and 2. So these are the 2 points. The second one is 4x is equal to y plus 4. If y is 0, x is 1. If y is 0. And if we take x as 0, y will become minus 4. So let us write the points here, x, y. X is 0, y is minus 4. X is 1, y is 0. We need to check the points once again. If we take the value of x as 1 here, if I take the value of x as 1 over here, this will become 4 minus 4, that is 0, so y is 0. If x is 0, y is equal to, if x is 0, y will be equal to negative 4. Now let us plot the first one. This is negative 2, 0. So negative 2 and 0, that will come over here. Negative 2 and 0 will come over here, this one. And then 0, comma 2 will come over here at this point. So let us join these 2 points over here. So this will be the graph line passing through these points over here. And we can, let me just change the color of this. So this is the line. Then, now let us take the other point, 0, comma minus 4. So 0, comma minus 4 will come over here and 1, comma 0 will come over here. So when we join these 2 points, the graph line will go like this. To pass through 0, comma minus 4. 0, comma minus 4. So it has to pass through this point over 0, comma minus 4. This is the point here. Now they are intersecting at this particular point here. And that point over here is 2, and this is 1, 2, 3, 4, 2, comma 4. And the coordinates of this is minus 2, comma 0. This is 0, comma minus 4. Little bit more has to pass through that particular point. Now, we need to find the area bounded by these lines in the x-axis. So which triangle are we talking about? We are talking about this triangle. This is the vertex A, this is the vertex B, and this is the vertex C. We are talking about this triangle over here. Area bounded by the lines and the x-axis. So this is the x-axis. So ABC is the required triangle over here. Now let's write the coordinates. This is minus 2, 0, 2, 4, and this is 1, 0. Now to find the area of this triangle ABC, area of triangle ABC, right, we'll take the help of the formula half base into height. Now here we'll take the base as AC. This is half AC into the height. Now this being an obtuse angle triangle, the height will be outside the triangle. So the height is obviously 4. Now base distance, base is 1, 2, 3 units over here. Whenever this is left side negative 2, positive 1, but we add the total distances 3. So this is half AC into, if I draw perpendicular like this will be BD over here. Right, so half AC into BD. This is the perpendicular. So you have to check on that, what type of triangle we get. In a obtuse angle triangle, the perpendicular falls outside near time. So this becomes half into 3 into 4. So this is 2 and you get the solution as 6 square unit. So the area of the triangle is 6 square units. So this has to be done properly. The next question that we have is, solve the following system of equations graphically. Find the area bounded by these lines on the y-axis. So now we'll have to draw the area, find the area of the triangle formed by these lines and the y-axis. So let's take the first equation, x minus y is equal to 4. So y is 0, x is 4, then y is 0. When x is 0, y is minus 4. Y is minus 4. So this is 4, 0, 0, minus 4. For the second one, we get here x is 0. I take the equation 2x plus y is equal to 8. Y is 0. Then x is equal to 4. Y is 0. Alright, when y is 0, x is 4. And when x is 0, y is 8. X is 0, y is 8. So x is 0, y is 8, 4 and 0. So when we plot the points, we get here 4, 0. 4, 0, sorry, 4, 0 will be this point over here, 4, 0. And 0 minus 4 will be this point over here for the first one. So we'll draw the graph line over here. And for the graph line, this is the graph line passing through these two points like. Then we take 4, 0 and 0, 8. 4, 0 and 0, 8. So the next one will be 0, 8 will come over here. 0, 8 and 4, 0. So the graph line, and 4, 0 is the same point over here. So this point and this point. So now we'll plot the graph here. This line will come like this. The point of intersection we have already got, that is 4, 0. The area of this triangle, right? Area of this triangle over here, okay. Area of this triangle bounded by y-axis and the two lines over here. The total distance from here, this is 4 units here, 1, 2, 3, 4, and this is 8 units here. So 8 plus 4 is 12. So base is 12, B is 12. Height is 4, H is 4. So half base into height, half into 12 into 4. That is equal to 24 square units. So the area of this triangle is 24 square units. Here again, this is positive 8, this is negative 4. But we have to add the two coordinates with a positive sign, because this is the total length. This is the triangle A, B and C. This has the coordinates 0, 8. This has the coordinates 4, 0. And this has the coordinates 0, minus 4. So height is this. This is the perpendicular way. This is the height. So the area of the triangle is this. So basically what you get in these type of questions is draw the graphs. If they are parallel, they are inconsistent. If they are unique solutions or coinciding solutions, they have infinite solutions, then they are consistent. So draw the graphs. Drawing the graph is not very difficult. You need to first find out the ratios. Keep in mind, find out the ratios A1 by A2, B1 by B2, C1 by C2. And once you know that, automatically the graphs will come out perfect. You will know that whether they are intersecting, they are parallel, or they are coinciding. Hope you like the explanation. Thank you for watching. Kindly like, subscribe and share the channel. Thank you for watching once again.